let's start over again from here. So we had two fractions with different denominators. First, we had to factor both. We did here and here. Then they weren't the same. One has x plus 2, the other one had x plus 2, x plus 3. So we needed to make them the same. So this one didn't have x plus 3, but this one had x plus 3. That's why we times this one by x plus 3. Then back to the second one. This one only had x plus 2 once and had x plus 3. It did not have x plus 2 twice. That's why we added another one here. So now after adding x plus 3 here, we're multiplying by x plus 3 and x plus 2 here. Now you can see that we have three factors and they're exactly the same. The order may not be the same, but we have three factors. That's exactly what we wanted. Once we have three, the same denominator, in that case, you can go ahead and add or subtract the tops based on the sign. But these stay the same, just like when you add 1 over 5 plus 2 over 5. So 5 or the common denominator stays the same. You only add or subtract the tops. That's what we did. So we kept the LCD. You can just write LCD if you don't want to write the whole thing again. And we added the tops together here. This one plus this one over the same thing, LCD and LCD. Okay, so that's 72. Any questions about 72?
No.
All right. Please let me know if you have any other questions. I'll try to do as much as possible.
What about 7.2 number 60?
Number 60 or 16?
60. 60.
60. All right. You guys see my screen, right?
Yes.
Yes.
Okay, so same question again, adding and subtracting fractions or rational expressions. So Shania is asking about 60, which is this one. So instead of that, we're gonna do 59, which is quite similar. Same steps, same concept. Okay, guys, look at this one here. Unfortunately, you cannot copy this to the whiteboard. It copies in a weird way. But let's see if we can. I'll try to paste it again. If not, I'm just gonna have to type it. Is everyone on board? Kala, Elva, Elizabeth, Fiona, Brittany, Paras, Ruby, Saleha, Shania, Sani.
Yes. Yes.
All right, so I'm about to do 59. Basically, we add in three fractions. So let me open the whiteboard again, which is here. Let me clear it first and see if we can paste. So it doesn't paste normally. Looks weird, but I'm gonna have to type it anyway. I'm gonna have to write it down anyway. So still under 7.2, question number 59. And again, you're doing 60 from the homework. So let me write it down again, 15 over y second plus 3y. So this time we add in three fractions instead of two. But again, whenever you add fractions, this has to be exactly the same. Obviously, it's not the same at all, so we're gonna have to make it the same. So what's the first thing I need you, you wanna find LCD. What do you do to find LCD? How do you make it easy to find LCD having three different denominators? We need to factor.
Factor. Yeah.
Right, factor all. To find LCD. Factor as much as you can. Some of them can't be factored because they're already factored. For example, this one. What is the common factor here between these two?
Y.
Y. That's right. We have y2 and we have y1. The common factor is the y with the lowest power, which is y1. Okay, they both have y. Y2, y1, but you're going to take the y with the lower power, which is y1. Open the parentheses. Now, if you remove one y, if we divide, because basically this one is y plus y. Right? Y2 means y plus y, times y. If you remove one of the y's, you move it outside. What's left?
1y.
Just one y, right? It's like dividing by y. If you divide this by y, you have one y left, plus. Same thing here. If you divide by y, or if you remove one y, what's left?
2y.
Here, 3, just the 3. So this y moves out, moves to the front, just like dividing by y. So this and this cancel out. Same thing here, 1y cancel against 1y. So here we have 3y by y will be just 3. Good, so the first one is factored. Do we need to factor the second one? Do we need to factor the second one?
No.
Just one letter, it's already factored, plus. Do we need to factor the third one?
No.
No.
It's already factored, so no need. So there's no common factor, so it stays the same, y plus 3. No, that's the first step, factor, then find LCD. After you factor, it gets easier to find LCD. Let's start with these first two. We want to make them the same. This one has y and y plus 3. This one has only y. How can we make these two the same? Forget about the third one for now. How can we make these two the same? What's missing here to look like this?
You can add y plus 3.
That's right. So this one has y. This one has y. This one doesn't have y plus 3, so it needs that y plus 3. Okay. If you times the bottom here by y plus 3, what do you do at the top?
The same.
Same thing, y plus
Yeah.
3. Good. So these two now are exactly the same. Very good. This one is not like them. What's missing in this one to look like these two?
Extra y.
The extra y. Exactly. They all have to have y and x plus 3 and y plus 3. So this one is missing the y. So if we times this by y, we're going to times the top by what?
Y.
Exactly. Also by y. Whenever you multiply a fraction by something, make sure you do that both the top and the bottom. See now, that's the LCD. So all of them have the same thing. So LCD is basically y and y plus 3. Okay, so just like adding, let's say you're adding these fractions, whatever, just some random fractions like this, plus 7 over 2. So if you were adding these three fractions, can we add them right away? Can we add these three fractions right away?
Yes.
Yes, they all have the same denominator. So we put 2 here. We just add the tops, 3
11.
plus 1 plus 7. Basically, 3 fractions with the same denominator. That's what we have here. We have 3 fractions. They all have the same denominator. So the denominator is going to stay the same, right? Just like here, 2, 2, 2, or here, y and y plus 3. What do we do with the tops? We have 15, 2y plus 3, 5y. What do we do with those? We add them, right? Because we have an addition, just like here. It's going to say 15 plus 2y
2y plus 6.
plus 3. And what else?
Plus
Y.
Exactly, plus 5y. Then you want to simplify that a little bit. How do you simplify that?
You can distribute.
You can distribute. So this stays the same, okay? So you don't need to distribute the bottom. Just leave it like that. We're gonna have to distribute this before combining like terms. It'll be 15 plus
Plus y.
2y plus 6,
6.
right? And plus 5y. Now we're going to combine like terms. We have these two together. That's 21, right? Plus what?
Plus 7y.
That's right. Over. The denominator stays the same. Again, you don't need to distribute it. Leave it like that. But can we simplify this more?
Which one?
You always try to factor. See this here? We have 21 plus 7y. We have y plus. Can we factor? So always try to factor at the end. Can we factor that?
No.
Are you sure? What's common between 21 and 7y?
Oh, 3.
7.
7. 7 is common. If you remove 7 or divide by 7, what do you have left?
3.
3 plus,
3.
if you divide by 7,
1.
Y.
that's right, just y. Over, this one is still the same. That's why I tell you not to distribute it. Leave it like that. You may need it to simplify. What do you think happens next?
And then you cross out y plus 3 on both, on top and the bottom.
That's right. So 3 plus y is the same as y plus 3. We can cancel those out. They're the same. So we have 7 over y left. So that's the final answer, 7 over y. Okay, so after you simplify, try to factor here. That way, you may cancel something out. And do not distribute the bottom, the denominator. Leave it factored because you need it. In this case, you see that we have a common factor, 3 plus y or y plus 3. We cancel those. We have 7 and over y left. Okay, so the main idea again here is, first you want to look at the denominators. If they're different, then you need to find an LCD. And to find an LCD, you may need to factor. It's very important because it makes finding the LCD easier. Once you factor, you kind of complete them, make sure they all have the exact same thing. If one denominator is missing something, you add it to, you multiply by that, and you must end up by very similar denominators, just like we saw here. Once the denominator is the same, it stays the same. Just add or subtract the tops based on what you have here, additional subtraction. Distribute if you have parentheses to simplify, combine like terms, and again, factor. Okay, factor at the end, and simplify. Okay, so that's what we did. That's why the answer is this simple. Okay, does that make sense?
Yes.
Yes.
All right. Anybody, any questions about this problem?
I have a question.
Go ahead.
So, okay, so what if we like leave just a part like the solution 21 plus 7y, like is gonna be
Well,
like
yeah, you want to stop here, right, at this stage? Well, you
yeah, I
won't,
mean,
you won't be the best answers. Look at this answer,
okay,
right? And look at this one. This one is much simpler, much nicer. So you may not get full credit, or you may lose a point, for example. If this question was 4 points, so it may give you probably 3 points only. Okay?
okay,
So always make your answer as simple as possible. Just like, for example, if you have, let's say 19 over 18 as an answer for a problem. Is there a better way to write this?
yeah.
You can say what?
Oh, it's like 1
1 over
and 9.
2.
Over 2, that's right. This is much simpler and easier. So always simplify your answers. So yeah, try to factor here. Don't distribute this, leave it like that, because we may need it to simplify.
Okay, thank you.
All right, very good. Still have some time. Please feel free to ask any questions. Everybody? Everyone with us will be Paras, Sanya, Brittany, Fiona is here, Elva, Elizabeth, Kala is here, Shania is here. Please,
What about
let's see if
homework
anybody
11?
else, Shania, before you ask, let's see if anybody else has a question. Anybody else,
Okay.
please, besides Fiona, Kala, and Shania. Everybody else, please let me know if you have a question. Okay,
I'm
so
okay.
your homeworks, your books, and if you're good, that's fine.
I'm okay. Thank you.
All right, go ahead, Shania. What was your question?
Homework 11, 6.5.
6.5, right?
Number, yeah.
Okay,
Number.
let me open the book. Give me 1 second here. All right, so I'm on the ebook. This time we're going to 6.5, so we're gonna go back one step. Gonna go back again from 7, go back to the chapter. So this time it's chapter 6. The unit is 6.5, right?
Yes.
Okay, let me open that. And we're gonna go to exercises. That's where the problems are. Okay, I lost it. Let me go back again. So 6.5 exercises. And what's the problem number?
Number 18.
18. So this is 1, 2. Let me scroll down. That's number 18. And I'll do 17. So 18, the question is solve each equation. Also, you'll see here examples, example 1 to 6. So the examples 1 to 6, all these problems are similar to this. So we're doing, let's say 17, which is this one, or 18. First, you wanna, after watching the videos in the course section, videos and animations, you wanna try the homework. And even before that, you can still see the examples from the book itself besides the video. So I guess done with this page. I'm gonna clear it. Okay, I'm gonna clear this. This is 6.5. Question is 17. 17 is the question we're gonna do. 18 is the question from the homework. We can do that later. So solve. Okay, what's the first thing we do again to solve this equation?
Bring all the factors to one side.
Standard form, right? Standard form. What does that mean? We need to move all to one side because it's a second degree equation. We're gonna move both of these to the other side with the equal sign. So x to the second stays here. What happens to 6x if you move it to the other side?
It becomes a negative.
That's right. Whenever you move something over the equal sign, the sign changes. So 6x becomes positive 6x becomes negative 6x. Negative 9 becomes positive 9.
Positive 9.
And what's the next step? So standard form. What do we do now?
You factor?
That's right. Factor is the next step, as we saw in the example. So again, back to factoring. So we need two numbers that multiply to what?
9.
Start two parentheses. So we need two numbers that multiply to positive 9. Same numbers add up to negative 6.
Negative 6.
What numbers do that?
Minus 9, minus 9. I mean, minus 3, minus 3.
Minus 3, minus 3. Let's check. So negative 3 times negative 3 is, in fact, positive 9, right? And negative 3 minus 3 is negative 6. Okay, so two numbers that multiply to 9. positive 9 and add up to negative 6. So you may try different combinations to get those numbers. Okay, so factor. What's the next step? Is to solve. What do we do with these two? Once we factor, what do you do?
You equate each equation to 0.
That's right. So we're going to turn these two parentheses, we're going to turn both of them into equations. So x minus 3 happens to be the same. So x minus 3 equals 0. And you take the other one also, which happens to be the same. If it's different, then you have to do two equations. And you solve each one. So after you factor, you say this equals 0, or the other side equals 0, and you solve this one. How do you solve this one? Just add 3.
Plus 3.
Add 3. That means x is
3.
0 plus 3 is 3. That's one solution. Sometimes it's the same, so basically it's going to be the same solution. And here also solve this, so same way. Add 3, add 3. So x is also 3. Okay, so when you solve second degree equations by factoring, this is by factoring. First, move all to one side. That's what we call standard form. Then factor. Once we factor it, set two equations or more, depending on how many factors you have. Each factor to 0, set it to 0, and solve the resulting linear equations. These are quadratic. The two resulting equations are the linear equations. So we have two solutions. You can write the solutions like this. S is 3. It's the same solution, so you don't have to write it twice. You just say S is 3. If you have more than one solution, then you write comma and the other solutions. So most of the time, these will have two solutions. If this was, for example, plus 1 instead of the same thing, you would have two solutions. So you write the other solution next to this one. Does that make sense?
Yes. Can you also have no solution?
Say it again.
Can you also have no solution?
It is possible not to have a solution, yes.